Now, here is a very interesting thing about hybridization. You know what is hybridization? Hybridization is a phenomenon in which these bonding elements take themselves to. They will tell that how a bonded molecule is seen. Have you seen an Eiffel Tower? Have you seen an Eiffel Tower? Suppose you are standing in the middle of the Eiffel Tower. How many legs does it have? 4 legs. And a top. So consider that 4 legs as a square plane and the top as your umbrella. And you will have a square tent-like shape. That square tent-like shape is known as a square pyramid. Got my point? So we will come to hybridization. The hybridization is a very important tool to understand the reactions also. In order to know the reactions, you need to know about hybridization. Because you need to know from where the attacking nucleophile or electrophile comes to do a reaction. Suppose you are having a BF3 molecule and you want to attack it with a nucleophile. So what will you do? You have to find out that in what hybridization state it is. Then you can say that the nucleophile will attack from this side and from that side. Okay? This is a basic funda about hybridization. This is a small example that I am taking. Now I am going to hybridization. See, there is a formula of hybridization in chemical bonding. What is the formula? Formula is half into number of valence electrons minus number of monovalent plus number of monovalent elements or molecules minus the number of positive charges. So there is a lot of confusion. If there is no monovalent ion, then if there is only bivalent ion, then. So just omit the formula. I am giving you a trick so that you can find the hybridization of molecule in no time. You can find the hybridization of any molecule and its structure in no time. How? Do you know how many types of bonds are there? Hello? How many types of bonds are there? There are 7 types. I am showing you. Single bond, double bond, triple bond, coordinate bond, singlet bond, additive bond and a lone pair. How many? 1, 2, 3, 4, 5, 6, 7. Just like the 7 wonders of the world, there are 7 types of bondings. So take all this. Don't be scared. It may seem like a Casper, but it does a major role in hybridization. So all this, take all this as one hand. How many? One hand. Triple bond will also be one hand. Coordinate bond will also be one hand. That lone pair will also be one hand. Do you know how many orbitals are there in S? Yes, you know it's 1. Do you know how many orbitals are there in P? Yes, you know 3. Do you know how many orbitals are there in D? Yes, you know 5. Do you know how many orbitals are there in F? It's 7, but that does not need to come here. Okay, let's end. Now, so you have taken one hand to all these things. You have given here CH4, NH3, SO2, BF3, H2, SO4, K2, Cr2, O7 and etc. You have to find out the hybridization. So how will you find out? How will you find out the hybridization? You have to do that calculation. half into this, into that, that. Lot of calculations. Just take carbon. You know the Lewis structure that I have taught you? The most electronegative one and surrounded by hydrogen, only two types of element. So it will be in the center and all the other hydrogens will be in the corner. It's very simple. So it has how many hands? How many hands? 4. So one hand will go to S because one orbital can take only one hand, which is of 2.5 kg. And the other 3 hands will go to 3p orbitals, electrons. So the hybridization of this carbon will be sp3 hybridization. Now NH3, again nitrogen, 1 lone pair, 3 single bonds with 3 hydrogens, hydrogen completing its duplet, nitrogen completing its octet. How many hands? You have to consider the lone pair also. 1, 2, 3, 4. Again it will be sp3 SO2. Sulfur. How many electrons? 6. 2 oxygen. 1 double bond. 1 coordinate bond. 1 double bond and 1 coordinate bond. And 1 lone pair. How many? 1, 2, 3. Then sp2 sp2. Got my point? Now BF3, 1 boron, 3 fluorines. Again the same sp2. Now H2SO4. We have already dealt how to draw a structure, and here it will have sulfur, oxygen, oxygen, OH. Okay? 1, 2, 3, 4 means sp3. Okay? In K2Cr2O7, you have to find out the hybridization of central chromium. So again, in that way, you have to find out which one will be in the middle, like that. Chromium, oxygen, chromium, O minus, K plus, double bond O, double bond O, double bond O, sorry, double bond O and double bond O, double bond O, double bond O, O minus, K plus, K2Cr2O7. See, I have told you, chromium will have, we can give how many electrons? How many electrons? 6. 1 electron to this, 1 electron to that, 2 electrons to this oxygen, 2 electrons to this oxygen, 6 electrons it has donated. Here also that thing. Now hybridization, just follow this rule now. 1, 2, 3, 4, sp3. A quick question. What will be the hybridization of this oxygen? Calculate by yourself. I'm giving you a hint. It has 2 lone pairs. Easy now? Good. Next. So all these things is how you will find a hybridization. It can have all these sorts of tools that you require to find out the hybridization. What does hybridization tells us? It tells us about the geometry.